Hello everyone, welcome to 1045 Engineering. So we are here in yet another video on the series Grind 75, a better blind 75. We had solved one two-sum problem in our earlier video. Let's look at the problem for today. So today we are going to solve the problem on valid parentheses. Okay, let's quickly move to the website and check it. Okay, so last time we had solved the two-sum problem. We can mark it, it's done. Let's go and solve valid parentheses. Let's go over the problem statement quickly. Given a string S containing just the characters, they are brackets actually, just the characters, opening, closing brackets or different types, circular, curly and square brackets. Determine if the input string is valid. An input string is valid if open brackets must be closed by the same type of bracket. Open bracket must be closed in the correct order. Every closed bracket has a corresponding open bracket of the same time. Okay, the problem is pretty straightforward, but let's go through the examples so that we can understand it better. If you see, this is a valid statement. So we have one opening circular bracket and then closing circular bracket. That is valid. In this one, there is opening circular bracket, then closing circular bracket, open square bracket, then close square bracket, open curly bracket, and close curly bracket. This is a valid statement as well. So the output is true, both of these cases. In this one, this is open circular bracket, but a closed square bracket. This is not valid, right? Let's say, just before starting, let's take an example. So if I am taking the example open circular bracket, then this, remove it here and put it here. Now this is not a valid bracket statement, correct? If I have done it something like this is valid. Something like this is valid, or something like this and this is valid, this is valid, this is valid, but this is invalid. So the opening bracket, so if we start from the innermost bracket, we can see that it is getting opened with a circular bracket and getting closed with a open with a curly bracket and getting closed with a curly bracket, and outside circular bracket and then circular bracket, right? So now we have made it clear what is valid, what is invalid. Let's jump to our solution. So please take a minute. You can pause the video if you want and see if you can look at the solution. The easiest approach that I'm thinking is for a string for us to validate is, let's say I get an open string and next time I'm getting a closed string. I'll check if the string right before this is a closed string or not, or if right before this, let's look at it here again. So it was open circular, then this, then this. So I'll check if the first character is an open bracket, then I'll move forward. Next character is an open bracket, I move forward. If it's a closing bracket, the previous one should match this closing bracket, and then I will remove this from the list. So I remove this, then this is the last one left, and the previous one is again a corresponding opening bracket, so it's matching. I clear this and we can return true this way. So if you want to take this approach, the easiest one would be to go with stack, and let's understand this. Okay, so let's quickly let's go with few comments as well. Create a stack to store open brackets. So as we discussed in our example below, right, if I get something like this, when I have an open bracket, I will store it in my stack. Okay, let's create a stack quickly for this. Stack of type character equals to new stack. Okay, now what if my first string or first character in the string is a, so there is one edge case. If the first character in the string is a close bracket, it can be of this type, or it can be this one, or it can be this one. If the close bracket is first, whatever I add in after this will not make any sense, because this will be invalid because of the first character itself. So let's put a edge case for this one, right? So what we'll do is check the first character, okay, and let's say character temporary equals to our given string, that is s dot caret 0. So as that caret 0 would mean the first character, right? We'll simply check if temp is equal to either it is a closing bracket of circular type, or temp is equal to a closing bracket of curly braces, curly bracket type, or temp is equal to, I think everyone can guess it at this situation, close square bracket. This would mean it's a invalid statement, right? So we can simply say if it starts with a closing bracket, it is invalid. So we'll simply return false, right? So we have covered the edge cases. Now let's deep dive that what if this is the first character is the opening bracket. Now we again have to go through the complete string to finalize whether it's a valid string or not. So we'll just loop through each character in the string. Okay, let's start. So let's start with for loop. For int I equal to 0, I is less than s dot length, because we have to cover the complete length of the string, I plus plus. And one more thing is, we are going to use only one loop to cover this. So overall time complexity we will be going for is O of n. So in terms of time complexity, we must get some pretty good score. Okay, let's see. So first we'll take the first character, that is s dot caret I. Okay, now C will get the first character. So if we consider this example, C will receive this one. Okay, now we want to check so right now we are not aware which type it is. We are aware that it's not a closing bracket type, but whether it is this type, or this type, but any type is okay for us in this case. Okay, so we'll say if C is equal to a closing bracket type of this, or C is equal to a curling opening bracket, sorry, I mentioned closing here, it's the opening bracket here, or the opening bracket type of square bracket. If this happens, then we will simply push this to our stack dot push C. Why? Because as we were discussing here, right, if when we get an opening bracket here, let's do it. When we get an opening bracket, we'll push it to the stack, so stack will have one opening bracket, right? Okay, we'll come back to this next time. Again, when we get an opening bracket, we again push it to this, so like this. Then when we get a closing bracket, we check it at the top of the stack, what is there, if it's the corresponding opening bracket or not. If it is there, we delete it. Then we reach the last one for the closing bracket, we check in the stack if the top of the element is the corresponding opening bracket or not. If it is, we close it. If the stack gets empty at this stage, it's true, means it's a valid string. Okay, let's move forward. So if it was of opening type, we'll keep inserting in the stack. Okay, but if it is not of opening type, okay, so if it's a closing bracket, we'll check if stack dot size is equal to 0. Okay, let me tell you why we are going to check for the size. Because if it's a closing bracket, we'll check whether the stack is empty or not. Okay, because if it's empty, there's nothing to match with, so it's invalid. So we are getting a closing bracket, but there is nothing to match from the top of the stack, so that means there is no open bracket available in the stack. That would make it the invalid statement. So we'll quickly write it. If it is, or if stack is empty, there's nothing to match with, right? Because if it's a opening bracket, we are pushing it to stack. If it's a closing bracket, we'll check in the stack. If at this point in time the stack size is already 0, that means it's invalid. Why? Let's look at this example. Suppose we had something like this and this. Okay, so first we got a opening bracket, we inserted in the stack here like this. Then we get a closing bracket, we check the stack size. Is it 0? No. So we check at the top of the stack, do we have a corresponding opening bracket? We do, so we remove it. Then we get here closing circular bracket. At this point in time, if the stack size right now, as you can see, it is 0, that means this is invalid string, because now we cannot match this closing closing curly bracket to any opening curly braces, right? Okay, let's move forward. So if this happens, we can simply say return false. Okay, now let's go one by one in each of the cases. If C is equal to closing bracket of circular type, if this happens, we'll say char ch and we'll look at the top of the stack dot peak, right? We'll get the element which is available at the top of the stack. If ch is equal to opening curly braces, opening curly bracket type, or ch is equal to opening square bracket type, what would it mean? So I have a closing bracket, but at the top of the stack the opening circular bracket is there or opening square bracket is there. That is invalid, right? For this to be valid, closing circular bracket should match with the opening circular bracket. So here we can simply say return false. Else if the top of the stack at this line we get the same closing bracket, we can simply say it's valid, or we'll simply remove this stack.pop. So now because of this closing bracket, we remove the corresponding opening bracket as well from the stack, right? This was one case for closing circular bracket. Similarly, we'll have other cases. I'll go quickly, is equal to closing circular bracket, curly bracket. I can say again character ch is equal to stack dot peak if ch is equal to circular closing type, or ch is equal to opening type, which opening type, right? Opening circular type or opening square type. We know it is invalid, we can say return false. Else we'll say stack.pop. This operation is same, this operation is same as the operation performed here. So what we are doing is we are performing all the operation for all of the possibilities of the brackets. So first we check for the circular, then the curly, and lastly we have to do the same for square bracket as well. So here it is ending. We'll say else if c is equal to square. I can directly copy paste it for just for everyone's sake. I'm typing it peak. Okay, so now we are matching it for the square bracket. If the c is of the if the character is of the closing square bracket type, and the character at the top of the stack is of other type, so it's opening circular bracket type, or it is equal to opening curly braces type, that would mean it is invalid. So we'll return false, right? Else stack dot pop, otherwise we'll remove it because it was valid, right? Now after all this, if now we see where did we start from. Okay, our for loop had started. After all this, if our stack becomes empty, where is our for loop ending? It's ending here. If after all this, if our stack becomes empty, that would mean that all the valid brackets have been removed from the stack, and it was overall a valid parenthesis string. So we can say return true. But still, in the end, if some elements are left in the stack, that means they did not have their opening brackets, or they did not get their corresponding closing brackets. So we'll say return false. Make sense? Okay, let's quickly try and run this. Okay, somewhere I have made a lot of mistakes. Let's look at it. Cannot find symbol S Y. Okay, chat at. I have written chat at rather than caret. Okay, typo is not good. What else is there? Bad operand type for binary operation. Where are we looking at? Line number 16. Okay, we are comparing it here, or C equal to this, or C equal to this. I'm not seeing anything wrong with this case. Let's see, where could we have gone wrong? So we are matching if C is equal to the opening bracket, or if C is equal to the opening curly braces. Let's run it and check it again. Bad operand type. What am I missing here? Okay, we're missing something here. Bad operand type for the binary operator. First type boolean, second type character. Oh, okay. I did not match it with anything, so that's why first type boolean and second type character. Okay, silly mistake. Let's run it. Okay, I'm hoping it should run this time at least. Okay, great. Let's quickly submit and check. Okay, we are actually getting a very bad runtime experience. I think we can improve our runtime experience further. 5.79% of the users with Java, but time complexity wise, memory consumption wise, we are good, but runtime experience wise, it's not that good. Let me just want to check it again. Yeah, I'm not sure why it was showing 5%, but now it's running in 2 milliseconds, and now it's beating 82%. but I'm still not sure because I believe we are at the fastest algorithm right now. Let's submit it one more time. Maybe we can push it. Okay, we reached 98.69% time. I think there was some caching issue from my end, or I'm not sure. But okay, now we are running this algorithm of n, and we can improvise it further in terms of memory consumption, but not so much in terms of time consumption. Overall, we cannot pull it below O of n. Okay, that's all from today's video on valid parentheses. Please, if you have any suggestions, comment them in the comment section. Share the video with your peers. So at the end of the day, like, share and subscribe. Thank you. Bye bye guys.